introduce Dr. Shang?
Sure. It's a great pleasure to see Dr. Shen here. Dr. Shen is my friend for many, many years. So we know each other when both of us were graduate students in the States. Dr. Shen has a solid background in food microbiology. In the meanwhile, he spent a lot of time and effort for food safety extension and also for the training program. Dr. Shen was the president of IFT Food Microbiology Division a few years ago, and now he's the president of IFT Biotechnology Division. So the reason I invited Dr. Shen for this workshop is because Dr. Shen is in a unique position to do a lot of very solid research works. But in the meanwhile, he has a very, very outstanding program for food safety extension. I believe he can give everyone a lot of very useful information, not only focus on the safety extension, but also focus on the research. So today he will give some introduction about the HACCP and the FSMA process, preventive controls for the human foods. Dr. Shen, it's your time. Thank you so much.
Good afternoon, everybody. Thank Dr. Ru for the nice introduction. And I go with Shen, S-H-E-N, so it's easy to remember. And I have my email and also my cell phone here. And I still do a lot of teaching. I do 40% teaching and do some research, but I have a 30% extension appointment with our university extension service. So I'm doing some talk with our local community, especially in the mountain area of West Virginia, sometimes in a big small farm conference in there. So the topic of what I'm going to focus on is the FSMA process preventive control for human food. We will not cover everything. We'll talk about is chapter 9, the process preventive control. But at the beginning, I would love to introduce HACCP a little bit because the concept is a little bit similar. At least carry on the HACCP concept, go to the process preventive control. So everybody knows the originals of the HACCP comes out long time ago, is in late 1950s by a company called FSMA. The reason is that at that time, the United States prepared to send people into the space. And those astronauts in the outside, in the space, they have to make sure all the food is 100% safe. Because if there is outbreaks happen there, then nobody can save them. So that comes out with a very proactive preventive control. We call it a HACCP, HACCP, which stands for Hazard Analysis Critical Control Points. Now, then there is a question for lots of people will be asking, since it starts the late 1950s, then how come the HACCP will be introduced only recent 30 years? The reason is this major outbreak really triggers the federal government have to force people to apply HACCP regulations. This is the one which has really caused the damage of the whole country. Is in 1993 in Seattle, the Jack-in pox. There is undercooked hamburger, the beef hamburger, contaminated with E. coli 0157H7 and killed 4 people. And those 4 are kids. And that's really a tragedy for their families. So we know that E. coli 0157H7 it have a Shigella toxin. Shigella toxin 1 and 2 will be attacking the CB3 target point of the kidney, cause blood diarrhea, and blood, kidney, and water diarrhea could be damage the neurological system, and the kids less than 5 years old is a high risk group. So that tragedy happened, which has touched the nerve of the White House. And that time, President Bill Clinton and Vice President Al Gore initiates the plan. The Congress must do something. So then they come out with a HACCP plan. And we can say that if this is not going to happen, we may delay the progress of those food safety actions. And something else is that I work in Seattle a year. That was back in 2010. There's a big company there called IEH Consulting Group, and the CEO is Dr. Mansosa Mandapur, and he initiated the rapid testing of E. coli. So E. coli 0157H7, of course, by the time is mainly focused on the PCR detection, but that is the initiation of the rapid testing methods right now is a very hot topic for the research area in the food microbiology area. So we know that later on, the Food Safety Inspection Service, United States Department of Agriculture, acronym USDA FSIS, has published this guideline, which is non-intact beef, including ground beef. You need to cook to the internal geometric temperature to 160 Fahrenheit, which is 71.1 degrees Celsius, which means they can kill E. coli 0157H7. Then comes out the Congress working with food safety person in FDA, USDA. At that time, mainly is USDA, FSIS. They published this, I would say it's a law, which is a Federal Register in 1996, titled as Pathogen Reduction, Hazard Analysis and Critical Control Points, Final Rule. In here, which is well documented, the 7 principles of HACCP. Including conduct a hazard analysis, establish critical control points, establish critical limits, will be targeting each critical control points. Then we say it's CCP. And we need to have a monitoring procedures to monitor the CCPs and establish corrective actions, verification procedures, and finally, the most important is record keeping and the documentation procedures. That is almost 200 pages long, the Federal Register, which is guide all the meat and poultry processors in the United States. You must establish your HACCP plan. Of course, they give the flexible for different size of the production. If you're a very small company, you can allow to have 3 to 4 years to establish the HACCP plan. Now here you will see interesting, they say it's a pathogen control. What are the pathogens they really talk about is Salmonella and the biotype 1 E. coli. So it's kind of a very ironic, it is not really targeting for E. coli 0157H7, but it's mentioned about the Salmonella, and we also know recently the Salmonella will be a zero tolerance in stuffed breaded poultry products in the United States, and the FSIS is going to announce that really quick. So we know there is a lot of the HACCP models published in the USDA FSIS web. If you look at that, majority of them, or 99%, which is beef and turkey, and chicken products, meat and chicken products, they are trying to develop some egg products, catfish. And if you look at the FDA website, before the FSMA comes out, they have 2 HACCP models, which is for seafoods and for the juice products. So there is a big chunk of the food commodities they did not cover is fresh produce. Because a long time ago, we always think fresh produce is 100% safe. And I can tell you, if you back to do the literature review, back 2000, back in year 2000, there is only 1 paper published, recognized by all the peers, which is Dr. Larry Bichon in University of Georgia. That paper talking about chlorine to deactivation E. coli and different food commodities. That paper almost cited about 800 times to close to 1,000 times. Because at that time, people doesn't do much research about fresh produce. They always think it's safe. However, these things happened. In 2003, in Salinas, that's a Central Valley of the California, fresh produce, fresh spinach is contaminated with E. coli 0157H7. And this is the first time in a packaged salads, they got the isolation of E. coli 0157H7. And they impacted almost 200%. 26 states end up with 3 people died. At this time, the people really recognize the FDA and the fresh produce companies have to sit down and talk about the solution for that. So they'll start to working together. University of Georgia at that time, leading by Dr. Michael Doyle, has doing a big grant for the fresh produce safety. And I remember in 2008 in IFP conference, his group have two posters talk about cross-contamination of fresh produce with chlorine. They had about 60 people look at the poster and you can't even get in there. And he had a workshop, a symposium. You can't even get to the door. And so that's the time we just initiate to do the fresh produce safety. Then where the FSMA comes from? People keep talking about we have to do something. By the time in 2000 summer, this really another tragedy happened, which is the Jason Farms in Colorado, which is cantaloupes outbreak. That is affected 147 person in 28 states with a very common pathogen, Listeria monocytogenes. However, it is an under-recognized pathogen in the fresh produce because it is everywhere during the fresh produce processing. People doesn't think about it's a real pathogen. Also in the meat products, it is ready to eat meat. Typically, people doesn't think it's a threat for the fresh produce until by the time. And look at here, 33 outbreak associated deaths. And very ironically, which is Jason Farms, has been passed as a third-party validation with a +A, with an A+ grade, just a week before this outbreak happens. And at the end of the day, people find because of the sanitation failed by the plants. Therefore, every part of the country is being very worried about this situation. And then they start to come out with this big one, which is Food Safety Modernization Act, acronym called FSMA. And everybody knows, which is signed by President Barack Obama into law on January 4th, 2011. So FSMA actually triggered by the fresh produce safety. Of course, is encoding fresh produce safety law. This is, we're not going to talk about today, but at the same time, it's carrying the HACCP concept and brings a new document, which is preventive control rules for human and animal food. We will mention about this. This is very tricky, the animal foods. Long time ago, any of the adulterant products you can easily to make as animal food. But this document has a new requirements. You cannot simply to make any contaminated human food. Said, I want to go to feed you dog or you cat. There is a new regulation for that too. Other than that, with the increasing of the trade in the world, this document, this rules also encoding international adulteration rules, third-party certification, transportation rules, all these type of things. And finally, it gives you some flexible, we call it complying with FSMA. Any of the local community, the small producers, if you're selling your products within 275 miles in the radius, in the circle, let's say if you have produced your sample in Toronto, if you want to sell to the area which is close to the University of Guelph, then you may not need to follow the FSMA law because that considered a local community, a local processed food. However, if you want to selling the foods from Toronto to McGill, there might be, you have to follow the rule because it's already past that 275 miles, the radius. Okay, so they talk about the 7 major rules, and here we're only going to focus for the preventive control rules of human and animal food. This is what I just mentioned, but I just want to be emphasize again is that the FSMA, they do carry on the HACCP concept. So like I mentioned, in 1996, there is a regulation, there's the Federal Register for the pathogen reduction, hazard analysis, and the critical control points. So document what I just showed you, and FDA has seafood and juice products HACCP plan generic model before the Food Safety Modernization Act come out in 2015. So what is the major difference people will talk about between HACCP and the FSMA, the preventive control? So I will say HACCP is simply, we talk about is hazard-based. And the FSMA preventive control is risk-based. This risk is a very broad-based risk, not only the bacterial pathogen. So the whole document is based upon the HACCP concept. They focus on what matters most for the food safety. It is a proactive preventive control. It's not a reactive, which means it does not mean we only need to do when something bad happened, we have to react it. We have to preventively to control that. It is in a company with, in conjunction with other programs, and we call those prerequisite programs for HACCP, such as good manufacturing practices. Another one is sanitation standard operation procedure, acronym is SSOP, and they all designed to minimize the risk of food safety hazards. So what they cover, we listed here. First of all, they are talking about critical process controls, the CCPs. Critical control points in the HACCP document, they do not mention it directly as a critical control points, they mention as process preventive controls. They are including sanitation preventive controls. Formerly, usually in the old HACCP plan, sanitation preventive control, we call it SSOP, I just mentioned is a prerequisite program. They bring in a new concept, a new introduction of the risk is allergen. Let's say you have a nuts, you have a fish, you have an egg, beans, all those type of things we call it allergen. As long will cause some immune system problem for the people in the United States. They all call it allergen. So it's allergen preventive controls is most important thing in this risk-based preventive control document. So you're also going to talk about supply chain preventive controls. When the supplier is expected to control potential hazards, our previous speaker has already mentioned that. And also you need to document a recall plan. And we know that there are 3 levels of the recall. Class 1 recall, which is a foodborne pathogen, a high risk. Class 2 recall, which mainly about is an allergen. In the older recall plan, is a talk about the allergen. And the third class 3 level of the recall is mislabeling. However, all these things, they all be underneath this preventive controls. So what we really think about each of the preventive controls are identified the need to cover the content is including the documented procedures, the critical limits, monitoring procedures, corrective actions, verifications, and recorded keeping and documentation. So you can see here, pretty much lots of the things from the HACCP it brings. Then what are the major hazards we're going to talk about? Previous speakers has already mentioned similar biological, chemical, and physical. Biological, everybody knows with bacteria, virus, parasites, molds, chemical, allergens, chemical compounds, physical, like metal detections, dusts, debris, any of the adulterants other than biological and chemical in the food products. So those are the 3 hazards will be covered. And before we talk about anything, when the company establish a preventive controls, they need to have a whole system, which is called food safety plan. This food safety plan needs to be including all these components, which is hazard analysis, process control, sanitation control, allergen control, supply chain program, and never forget a recall plan. If it's really outbreak happens, what does the company have to do? So this is a whole thing, talk about the food safety plan. And there's a menu, which is published by FSPCA, Food Safety Preventive Control Alliance, which is established by Illinois Institution of Technology in Chicago, Illinois. They published this menu, which is about 500 pages long, including 13 chapters. So what we are talking about here and I'm going to talk about is process preventive control, which is in chapter 9. In this module, we are covering 3 major items. Number 1 is critical limits. Number 2 is monitoring procedures to make sure the critical limits is well controlled and the critical control points is achieved. And the last thing is corrective actions. If any of the deviations happens, which means the critical limits is failed to reach and the critical control points is no longer well controlled, then we have to do something that is called corrective actions. So those are the 3 major points we talk about. And first of all, since the slides has not been mentioned, I would love to review what we talk about for the critical control points. So what is that? Critical control points, the definition is a step or point of the food during the food processing will be to reduce or eliminate or reduce a food safety hazards to an acceptable level. Now, they use the words which is eliminate or reduce. And I would say in the food processing conditions, most of the time it is reduce, not eliminate, unless there is some of the zero tolerance requirements. Let's say E. coli 0157H7 has to be zero tolerance in ground beef and non-intact beef. Majority of the time it is reduced. Let's say salmonella in a poultry carcass. Unless your plant is less than 10.4%, the capital 7.4%, Capitalobacter is less than 10.4%, the plant is passive you can say investigation or like testing. Listeria monocytogenes in a ready-to-eat meat, as long as it's less than 1 cell per 25 gram, it is past the testing. So it's not really zero tolerance. Another thing I also want to mention is that when we say reduce, if you look at these days, all those sanitizing, they all put on the label said it is 99.9% germs, Q99.99% germs, which means it's a 3 to 4 log reduction. That is most of the regulations we'll talk about is like 3 to 5 log reduction. Because on the food contact surfaces or in the food products, we are very difficult to achieve zero tolerance. The reason is that there is a 3 different levels for the control pathogens, including sterilization, like you do the autoclave, curing everything. Second is disinfection, like you use alcohol to do the cleaning in the surgery room. And the third level is like sanitizing. So when we talk about the food products, we are focused on is a sanitizing. That's a relatively low level of the control that we talk about is 3 to 5 log reduction. So that's something I would love to review before we talk about these details. This is a black process control form designed by a model. If you are working in a company as a quality assurance people or a lines person or a manager or manager control person. So at the beginning, you're going to put product, plant name, address, the issuing date, and the schedules right there. And then you're going to mention the process control. That is actually the old CCP, critical control points. What's the hazards we are recognized? And these 2 parts we already talked about in the previous speakers. So I will focus on is the critical limits in the third box, monitoring procedures, what we're going to do, how we do it, how often we do it, and who will do that, and the corrective actions. Verification and the records, which is in chapter 12 and 13 of this document. So this will be talked later on in the future if we have an opportunity. So we basically going to talk about is right in the middle, all those 5 lines, 6 lines. This is a model by the FSPCA. They help you to design and recognize the process control and hazards. So I'll give you example. If this is an omelet, you know the omelet, which is made by cheese, some of the biscuits, some of the flour, and there is some of the hams there. It's a mixer. And what is a process control? What is a critical control points? Of course, is a cooking. We need to reach a certain internal temperature. And what is a risk? Salmonella identified as a risk because recently there is several recalls or outbreaks related to that. So that's why salmonella will identify as a hazard. And once we have that, then you're going to ask a question. Do any potential food safety hazards require preventive control? Of course, you're going to click here, which is yes. So how are you going to justify? We can do a cooking. If we do a roughly cooking, we can kill vegetative pathogens. Here, I'm not sure you recognize that. It mentioned very clearly here is a vegetative pathogens. That means the bacteria, which is normally grow in broth or in the food products, which has a contrast concept, which is the biofilm. If we talk about the biofilms, that's another story because they're most likely will resistant to the sanitizing procedures, including sometimes the heat treatment, although we don't talk about that too often because most of the time the biofilm is on the surface. And then what preventive control measures can be applied? Of course, cooking to achieve a lesser temperature. I don't know about the exact here, we'll find it out. Most of the time in meat products, 71.1 degrees Celsius internal geometric center temperature. For poultry products, a little bit higher, 74 degrees Celsius. So this is the overall table, tells you the concept. So let's move on to these items. Number one, critical limits. So here we're going to talk about the definition of a critical limit. How are we going to determine critical limits targeting a critical control points? That has to be specifically focused. So what is the relationship between critical limits and the operating limits? I believe we will talk about operating limits or at the end. And the last, we also going to fill the form. So we use the process control form to finalize the critical limits section underneath this form. So first of all, what is the definition of critical limits? The definition is pretty straightforward, which is a maximum or minimum value or a combination targeting a biological, chemical, or physical parameters that can be controlled that can be achieved to minimize or prevent a hazard requiring a process control. First of all, I want to say here, this value, this parameter here, we talk about biological, chemical, and physical. Most of the time, in 95% of the scenario, we talk about is chemical and the physical parameter. Biological parameter randomly mentioned, I will say the most frequently we mention about is the zero tolerance of coliform and fecal coliform in the drinking water system or some beverage products. Biological parameter, we did not mention that too often. The reason is that the rapid testing for microorganisms so far, it's getting there, I will say, but has not been really commercialized for every places in the world has using the rapid testing really in these type of the regulation standard procedures. So we are talking about here is chemical and the physical parameter. The second thing I want to mention is the parameter, you have to be measurable and observable, which means we can measure it or we can see it. It's not something just suddenly jump over our mind, the numbers we have to achieve. The third thing I also want to mention is in FSMA, process preventive control, it allows you to use a range. Sometimes, for example, larger or equal or larger than which number. In the old HACCP plan, this critical limit has to be a fixed number. They do not allow you to use a range because when you use a range, the control level they think will be decreased. And of course, all these coming from Code of Federal Register. That's why we have a CFR all the time. That's called Code of Federal Register. Now, the first question is, after we talk about the critical limits concept, where are we going to find the resource of these critical limits? There is a several listed, 5 listed information sources. They also, at the end of this document, which is in the attachment area. First of all, since FSMA is initiated by FDA regulation, it will be a source for the critical limits. They have some. For example, acidified foods regulations. They targeted pH 4.6. Food code. There's a lots of the chemicals, physical parameters there. Pasteurization milk ordinance. They mention about 70.1 degrees Celsius, 15 seconds for flashing pasteurization. So of course, it's from FDA. We also could get from the local or state governments from their regulations, including USDA regulations. The third one, we could get some of the experts from this area. In United States, let's say my university, the Dr. Lu's old university in Washington State University, West Virginia University, my old school, Colorado State University, we are 8062 land-grant university. Our mission is teaching, research, and extension. So extension is our part of the job. Therefore, there are lots of the extension specialists. There are 100% extension appointment will help the local communities to do the consulting. And those people are the good resource for consulting about a source of the critical limits. And some of the company, let's say Eurofin, IH Consulting Group, Silica, all those companies has a microbiologists, consultants could do, is a good resource for consulting. Sometimes the companies, they will do some validation study or the challenge studies. Some of them published, some of them not. So we call it in-house experiments. There could be a resource for critical limits. The last, obviously, we know because we are doing the research all the time is a peer review publications. So I will say example, Journal of Food Protection. Although it doesn't have a very high impact factor, but in the for the industry area, there are lots of very applied research. There's a resource for critical limits. But here we want to mention is that why they listed the scientific literature is at the end. Because the scientific literature's research most of the time is focused in the lab, and the lab condition is very optimal. It is very different from the real life scenario. So we often find antimicrobials work very well in the lab situation. However, when you move into the real life processing line, it maybe lose the function, sometimes the same as a water treatment. Another example is that if you wanted to see the thermal inactivation study, in the real life, lots of the meat products, their fat components is high, is about 10 to 15, 20%. But most of the publication, their fat content is only like 3 to 5, because the fat will make the bacteria resistant to the thermal inactivation. So those resources need to be double checked with the products what you are using. You cannot simply just say somewhere published something, can I just borrow their data to set up critical limits? Sometimes will be misleading you even. So that's why the scientific literature is at the end of these sources. Critical limit considerations. Of course, it is important because if a critical limit is not met, a hazard is not under control, and the safety of the products will be in question. The second is that the critical limits must be achievable. Most of the time, we will mention this later on, most of the time, we will set up the cooking temperature a little bit higher. So for example, if the critical limits is 160 degrees Fahrenheit, 71.1 degrees Celsius, we may set up a little bit higher, 165 degrees Fahrenheit. say 72 degrees Celsius. And because we are trying to make sure the critical limits is controlled. Now, of course, you need to make sure that your cooking appliance can achieve that temperature. If the cooking appliance cannot achieve that temperature, what you have to do is maybe you have to cook a little bit longer time. Therefore, there comes out another consideration is offer a variety of options. So for example, I have lactic acid to control salmonella in a poultry legs, in a poultry drumstick, post-harvest. And the day I do not have lactic acid, I have to use citric acid. Saying that's an option, that's a variety of option. Then the concentration may be different. Therefore, you need a previous validation study to confirm it could be used. So that will be one of the examples for the variety of options existing for controlling a particular hazards. Now, of course, the last one, in every company, I believe there is some of the food safety experts, they will be select the best control option, and they based on their practical, their situation, their experiences, their historical recording information to make the decision. So those are the things could make a consideration for the critical limit. Another thing I also want to mention for the variety of options, that could be a combination of a temperature, time, oil amount, moisture level. If you're making some of the mixed products, let's say omelette, you can see these days, most of the outbreaks, they are not really happen. Only a single product, let's say ground beef, let's say a hot dog. Most of the time you see the recalls happen in the pizza. In like omelette, all those type of a mixed products, which is from the food ingredients from different resources, that's the most high-risk group right now, because we need to consider a variety of these options to control that. It is hard to do lots of the time. So here are the examples of the critical limit. Let's say we have a battered product. Staphylococcus aureus is a toxin. The toxin will formation. So the critical control points will be a better application. So how are we going to do? How are we going to set up the critical limit? Does not exceed 10 degrees Celsius, hydrated batter for more than 12 hours, or a little bit high temperature, 21 degrees Celsius for more than 3 hours. Chopped product. FSMA mentioned about a metal detector. We don't want the metal ingredients there. So metal inclusion, we're using metal detector as a critical control point. So what is the critical limits? No detectable metal fragments in finished product, and knife blades are intact after each run. And this is really hard to do. More or less, you happen these bladed sometimes this intact. Okay, this is hard to do if you do manually by manually. High water activity ready to eat foods, that including hot dogs, we call frankfurters, turkey, breast, pathogen growth, Listeria monocytogenes is typical one of them, involved in the outbreaks in the early 2000s. Cold storage is one of the critical control points, but I don't think it's enough. Listed here, the cooler temperature, less than 5 degrees Celsius. This number, I always believe it has to be fixed because our dangerous temperature zone is 40 to 140 degrees Fahrenheit. This is obviously already reached the dangerous zone. So this is just an example. Please don't use it if you work in the company, just borrow these, to use your own products. Some of these a little bit contradict from the previous published document. Ready to eat cooked and refrigerated product, Listeria monocytogenes just mentioned, critical control points cooking, need to reach internal temperature 70 degrees Celsius, the cooking time 1.5 minutes. This is most of the time there is a resting time. We talk about is after cooking. You're not going to directly to do the packaging. You have to hold on there about like 3 minutes, and we see the temperature change. Sometimes it's going to increase a little bit, especially the internal temperature. dry the product, passing gross drying oven. And here set up the temperature, time, and airflow. And be careful about the thickness, because the thickness, always the time, will be impacted the thermal inactivation and also the drying process. We have the validation study find that the more thick sometimes require longer time to cooking. If it's not evenly distributed, the ingredients, there's a cold spot there even. So that's have to be careful about the thickness. Therefore, the company most of the time has a sizing board. The sizing board will reject the thickness if they reach certain level. Acidified products, Clostridium botulinum. It's an endospore forming bacteria. Critical control point, acidification. Now the critical limit, they have to product weight less than 100 pounds, soaking time more than 8 hours. That is pretty long time. Acidic acid concentration more than 3.5%, and the volume they put as 50 gallon, and achieve minimum pH 4.6 because that's a number for the low acid food. pH 4.6, water activity around 0.85. So here is an example, talk about the critical limit. We talk about the frozen omelet. The hazard is salmonella. The critical control point is cooking. And the critical limits is 158 degrees Fahrenheit, 70 degrees Celsius. What is the applied target? Is individual cook and batch processor, which means you put oil in a pan and you cook it. This is just an example. In the real life, it is very difficult to do. It is also unrealistic and unreasonable. You use thermometer and or thermocouple to test each individual sample, because the omelet after cooking, you know, the morphology or the shape will completely change. It is also hard to determine the geometric central temperature. So this is just an example. I won't say it's a very good example, because for the products like frozen omelet, if you are in a company, it's not a really good idea to check each individual. What you have to do, same hazards, same critical control points cooking, you will choose a different critical limits because you use a belt fed oven, they're on the belt. So you're gonna control oven temperature is a critical limits. The belt speeding and the batter volume in a standard pan size, there's 3 critical limits. This need a very rough different combination of the validation study to verify the oven temperature, belt speed, batter volume is working, because that's more realistic. If you produce a huge amount of the frozen omelet in the morning to send it to like other suppliers or other distributors. So here is an example if you're a large process. So we're gonna fill the table right here. Process control cook, hazards, salmonella, critical limits, frozen omelet. We are set up is a physical parameter, the temperature, 150 degrees Fahrenheit, 70 degrees Celsius. They will be instantaneously, we say right immediately before transfer to assembly table. Therefore, we're going to talk about the next one is the monitoring. So in here, we will mention the definition of the monitoring, the purpose of the monitoring, how we're going to design a monitoring system, and the methods and the required equipment for monitoring critical limits. First of all, same thing, 21 Code of Federal Register gave the definition of the monitor. So what is monitor? It is a planned sequence of observation and measurements to assess whether control measures are operating as intended. I would add a couple of sentences here if you take notes at a specific frequency, because lots of the time, the small processors, some people in our local community in West Virginia, they will have the impression monitoring, I only need to check one time. Lots of the people will just walk there to see, okay, it's good, it's working, I'm gonna start to do the processing. It's all good. That needs to be done in a specific frequency. Most of the time, a typical example is you do once at the beginning of the shift, of the shift, at the end of the shift, and the one is at the middle of the shift. If the shift by a different person, then between that, at the beginning of the second shift, you do it again. So that's at a specific frequency. That is important. So the purpose of the monitoring process control is we have to document the minimum and the maximum value of critical limits. We want to make sure it is met to ensure food safety hazards has been controlled. Because if it's not controlled, which means there is a deviation going to be happen. And at that time, the deviation happens, which means the critical limits lose the control, then we have to do is the corrective actions. And at this moment, we need to provide a written document that can be used to verify the process is under the control. So it's end up with next questions is the elements of the monitoring. So what to monitor? We are going to talk about the measurements, what the measurements and the observation will be to do. How are we going to conduct the monitoring? How frequency, how often we do the monitoring, and who will do the monitoring? The last question is actually kind of tricky. So first question, pretty obvious. What might be the components can do the monitoring? Here are some of the examples. I will say, if you study a little bit of food microbiology, I will say most of these are the external factors to impact bacterial growth. For example, temperature, time, pH, acid, water activity, chemical concentrations. Here, we most likely talk about antimicrobial concentrations. Those will be impacted bacterial growth. There is some of the components here, the examples here, we are talking about the processing line. Let's say the volume, weight, line speed, flow rate. Some of here, we also talk about a specific products. Acid addition, if a low acid food, we add citric acid there using a high pressure cooker and to make sure the pH is less than 4.6. pH, of course, is important. If it's regardless is acid or non-acid food, the pH is always important. Very tricky for the bacteria to grow. You cannot control that very low. Sometimes the low is not means it's better because the quality going to be loose and also will generate acid resistant bacteria. Water activity. This is the one you have to control because that means available of the water you can use. It's a different concept between the water activity and the moisture contact. The moisture contact, which means amount of the water in the food products. So water activity is we talk about the vapor pressure of the products. That means the water available to be used by bacteria. So water activity control is important. Low acid food water activity around 0.85. Chemical concentrations, we have to monitor it. Appearance. I think the appearance here will be some of the obvious reason. If you see a food products have a greenish color there, then that means it's already been contaminated. The shelf life will be terminated. You can't have to process it. So appearance is obvious things to do the monitor. But I think if you see it, it will be too late to do sometimes. Here listed many others. In the FSMA, they mention about metal detector. So make sure when you do the monitoring, the metal detector is on. And also the sizing ball is control the thickness is another example. Make sure the sizing ball is working. They will reject the thickness of the products if it's above the certain level. So how is monitoring conducted? We know that the monitoring conducted is very important. We need to make sure the whole food product is covered as much as possible. We need to avoid a cold spot, a niche area, or some of the places hiding is difficult to reach. And one of the obvious example of the monitoring is we do the calibration. So we calibrate the thermometer at the beginning of your cooking using a water bath to see the thermometer whether it works in the cold temperature, room temperature, and a little bit hot to see whether it's changed. Calibrate the pH meter. We prepare the buffer at the pH 4, 6, 9, or 10 to make sure it works. Calibrate the charter recorder. Make sure the charter recorder is recording every 1 second, every 5 seconds, 10 seconds, depending on what you need. And lots of the time we can do inline analyzer. Let's say operational reduction potential or p-value. Fresh produce company can do the online monitoring to see the level. Lots of the time we say real-time laboratory analysis, but I have to be emphasized about not really real-time. It took a couple of seconds, couple of minutes, 20 minutes. At this moment, what you have to do, the product have to be hold on, okay? Until the results has been coming out for the decision making, what's the next steps you got to do? Most of the laboratory analysis not really real time. It's going to be delayed a little bit of time, sooner or later. And visual checks. Visual checks here is still mentioning about metal detection is on, reject device is working. Monitoring procedure. There is 2 different levels of the monitoring. Number 1, we call it a continuous monitoring. It is preferred to use because we can always make sure the products in the processing line is monitoring all the time. And most of the time is even can print it out the data sheet, you can see it. And it saves a lot of the energy, lots of the human being labor work to do the monitoring. So continuous monitoring is preferred to be used. So for example, the temperature recording chart during the cooking, the metal detector, the inline pH probe to testing the pH level of the processing line or the fresh produce water, the barcode scanner, and also some of the vision system X-ray detection for the foreign materials. That's a continuous monitoring. But here is something has to be careful. We will rely on the machine to do a continuous monitoring. Our human being has to be jumping sometimes. That means the human environment needs to be occur periodically. The human check needs to be involved periodically. So I give you an example. If we are testing operational reduction potential in a fresh produce water system, fume system, you can't just rely on the machine to do, because once your organic matter is accumulated, the ORP value is higher, is even much higher than beginning. However, at that moment, the free chlorine concentration is actually decreased. So you have to be based on your food safety plan. The ORP, you have to test it by human being to do using a manually tested to compare the machine. What's the difference between that? And you can't just go there to completely rely on the machine monitoring, okay? Non-continuous monitoring considerations. We mentioned about continuously. Of course, sometimes we can't do that continuously in the real life because the technology is not there yet, and it's not feasible, economically feasible to do that. So it comes out with a question: how we should to do it, how frequency we do it, how often we do it. It really depends on the 3 major issues. Number 1, how much does the process normally vary? If the variation is way too large, for example, your variation of the cooking equipment is 5 degrees Celsius difference, then the monitoring you have to check more frequently. Second, how close are the normal values to the critical limit? If your normal values almost same as a critical limit or just a little bit above, of course, you have to do a more frequent checking. Last is amount of the product. What's the volume is at risk if the critical limit is not met? If more products involved, we have to do more frequency of the non-continuous monitoring. Here, we gave you some of the examples of the non-continuous monitoring, including the temperature check at the specific intervals, batch process check, water activity check. And you know water activity, you can do that the real time. We work in the lab as a student, as a faculty, we know that we have to set up the standards, use a different formula of the salt concentration, and then we have to put them, cover the cup and put them into the machine. When you're waiting for the beeping, and it usually take 5 minutes to get a number. So we cannot do the continuous monitoring. Last one, antimicrobial chemicals in the produced wash water. If you are testing chlorine, we're using DPD methods. That took about 2 minutes to get a number. And if we are testing perioxyacetic acids, we use titration methods that are also taking about 2 or 5 minutes to do, or longer than that. So those are non-continuous monitoring examples. Exception records. When you first see these slides, you will feeling it is a little bit confusing you, but I give you an example. You can understand it very well. What is exception records? We all have these experiences. When you go to buy a grocery, you buy a lot of foods, a bag of fresh produce, a bag of meat, a bag of chicken, some ice creams. Then you say, okay, let me open the door of the refrigerator. Then you open it. You spending time to organize it. After 3 minutes, the refrigerator start to beeping. Then they start to give you alarming. And sometimes you never do it in the home, but in the food industry, there is a data sheet can print it out, which means the temperature is above the control. That is exception records. So here, which is talk to you about cooler records, when temperature goes above a set limit, will set up with alarming. So will tells you, the line person, this refrigerator, the cooler is not working. Exception records rely on an automated system. The automated system is really good to be used because if it's used more efficiently, it will control some of the human error. Because if you go ahead to read the thermometer, sometimes you made a mistake. You may misread about that. It depends on your work amount. If you can automatically read it, have an alarming setup, it works very well. However, this system, you need to validate it. Make sure the automated system is really working, checking more frequently, at least a couple of times during a month period of time or week period of time to make sure the automated system is working. So this is exception records. Next question, who will monitor? I'll say this is a tricky question. Lots of people will say a supervisor is a good monitor because it's already called a monitor. So you're going to see the people who's doing well. Is that true? Yes, it can be a choice, a supervisor. How about quality assurance person? Yes, that could be. Lots of the company have a QA position. If you see the job attachments, they're doing the monitoring. But who is the best person to do? The best person is obviously a person is well-trained with food safety knowledge, designated because he knows the real processing line, how the food products. So who is the best person really to do the monitor? Is a lines person, is a machine maintenance person sometimes, because not only they need to know the processing, they need to have a little bit of background about the food engineering, how the machine is working. And also very important, these people have to have the training, and the training encoding, they need to verify, the monitoring procedures. Last thing, if the monitoring, you're changing the person, let's say the person who is being out of the plant for some of the reason, for maternity leave or vacation for like a couple of months, if you're using a different person, make sure he knows the updated system. Okay, that is also important. Qualifications for the monitoring individuals. This is we already mentioned. trained in monitoring techniques. This person does not require you must have a preventive control training, but must have a food safety training. You better have a FSMA training, got a certification. I would recommend that. Fully understand the importance of the monitoring, because if the monitoring failed, which means the critical control limits failed, the critical control points is not under a control. They have to accurately report each monitoring activity, when, where, what happened, because understanding actions to take needs to be taken when the deviation occurs. And that is in coding, you sometimes need to take immediately corrective actions. And you also have to do a timely report of the deviation for the other action. This is an example which is showing you the monitoring. So let's say we're using omelet as an example. As always, what are we going to do the monitoring? Temperature 158 degrees Fahrenheit, 60 degrees Celsius. How are we going to do? Like we said, it's difficult to testing internal temperature. So we're using the surface thermometer. Who's going to do it? QA technician or a designate to do it. Here I want to mention, I would not say the QA technician is the best choice based on the content of this menu. I would change this lines person, maybe an appropriate name for this. And each cooking station, how frequency each cook station, how often, 4 times per shift, about every 2 to 3 hours. This is a final table almost. We see the hazard, parameters, the critical limits, values, how, who, how, frequency we do it, and the corrective actions. So we got to move on to the last part, corrective actions and the corrections. Here we're going to talk about the definition of corrective action, corrections, the procedure for the corrective actions, record-keeping requirements for corrective actions. First, the same thing is the definition. You can read through all of these coming from 21 Code of Federal Register. So you can think about yourself, what is the major difference? Corrective action is a procedure. The keywords is a procedure. Correction is an action. Both are the major components of the control management system. What is an action? An action, most of the time, is a sporadic and a major fixing. However, corrective action is a deviation happens is a whole procedure. What is a correction? If you're walking to the lab or to the plant in the morning, 8 o'clock, you start to processing the hot dog. You see the ground beef start to do. However, the cutting board is not cleaned. They forgot to clean that yesterday. You will say, okay, everybody, please hold on. Let's clean, sanitizing this bench first. This is a correction. However, if this happened very often, then it is not a correction. Then it becomes a corrective action because it's going to end up with deviation going to happen. Therefore, you need to go back to see the documents, how they did every day. What's the concentration they use? What type of the sanitizer they use? Who did that? If there is a thing happens, then you need to fix it. That is a procedure. Is not a sporadic, is isolated fixing. Okay, corrective actions. They must be taken when process preventive controls are not properly implemented, because they will result in a deviation, which means there's a deviation from the critical limit. The reason why it is important, if you don't do corrective actions, the unsafe food will be produced. And so how to do the corrective actions, we need to understand the nature of the hazards and all those, the preventive control. So here is something we need to do. We mentioned about corrective action is not a correction, it's a procedure. So what are the procedures we have to focus? There is several steps recommended by FSPCA. First of all, is identify and correct a problem with implementation. At this moment, I will say the first thing what you should do is empowerment of employees. Stop in line. This is hard to do. I tell you, people working there day by day, if you ask them to stop, they may be a little bit not unhappy or even mad. So what we should do, they have to be trained with the food safety concept. We need to create a food safety minded culture in the company. They recognize the importance. This is for the food safety, not for the personal, not for the personality. You need to reduce the likelihood of the occurrence, especially the reoccurrence. So if you're doing the corrective action every day, so you find every time that the thermometer is not controlled very well, the temperature is a big variation. What we should do, maybe the machine needs to fix it. If the machine keeps to fixing a couple of times a year, maybe we have to put a new machine there. That is the way to reduce the likelihood of the occurrence. Then we have to evaluate the affected food for safety. Now, at this moment, I will say this food, you need to see how much amount is going to be affected. Microbial testing is a choice, but not necessary. Because even we do micro testing, does not 100% mean micro safety. We do have a plan, which is a class 2, class 3 sampling plan, focusing on the microbial testing, but it really depends on what type of the products. Last, prevent affected food in entering into the commercial. If you can ensure it is not safe, it is not adulterated. This is you need to document it. Most of the time, you will say you disregarded. Not necessary. Like I said, all the time, make as a pet foods. We have a new regulation right now. That's not easy to do. So another good example, if your ground beef has E. coli 0157H7, what they allow you to do is cook to ready to eat meat, make a hot dogs. That is allowed to do. But I tell you one thing, there is a joke, we always heard about that. Lots of the person do HACCP training all the time, they will tell you, as they will randomly eat hot dogs because 40 or 50% of the hot dogs in the States, they are coming from those adulterated ground beef. That happens all the time. But I tell you one thing, that is a choice. So completely disregard of the food products is not really a choice, but it could be, but not really a first option. Some of the examples about the corrective actions. Number one, the process examples, immediately adjustment of the process. This could be done, but make sure it does not done very often. If you every time you're doing immediate adjustments, that means there's a problem behind that. You need to look back at the food safety plan. Like I said, employee stop line when deviation occurs, empowerment of the stop, this needs to be a culture, food safety culture, the mind in the company. Most of the time we are using is apply alternative process. So I mentioned earlier, if you're cooking at 160 degrees Fahrenheit for 5 minutes for omelet, this time is only 159 degrees Fahrenheit. Okay, maybe we cook a little bit longer time. For 7 minutes, might be works. However, this needs to be previously validated in your food safety system. Some other examples, repair equipment, retrain employees, evaluate the operation. What's the products we have to do? Obviously, hold on the product. Don't go to the market, because when you go to the market, you have to initiate a recall. That's another story. Evaluate the product, the amount, the level it's going to be infected. Last, determine product deposition. Release, rework, or destroy. Like I mentioned before, could be make into pet foods, but new regulation FSMA have animal foods. You have to follow and also make to ready to eat meat if it's a ground beef contaminated with a bacteria. Unanticipated problem. When we set up a preventive control, it does not mean we're going to cover everything. However, if there is an unanticipated problem happens, you must also to really document it. There are some of the examples encoding here, which is unanticipated problems. Number one, preventive control not properly implemented, and a corrective action procedure has not been established. Number two, one or more preventive controls are ineffective. This is not a human error. Sometimes the validation study is outdated, or there is no new emerging pathogen comes out. The control is not really works, then you have to update it. So that is unanticipated problems most often happens. The last one, review records find the records incomplete. The activities did not follow the food safety plan, and the corrective action is not appropriate. And those are the examples. So end up with how we're going to do. Standard, of course, even the unanticipated problems happens. We still have to follow the standard corrective action procedures. In coding, you identify and corrective and implementary problem immediately as soon as possible. Talk to your supervisor, those has to be hold on. Then the supervisor has to have a team to look at the resource, especially the historical resource of the recording, reduce the likelihood of the occurrence. Another means which tells us you need to find the root cause of the problem. If the machine is really not good, redo it. Buy a new one, fixing it. Evaluate all implicated product for the food safety. This again, amount, what's the level it's implicated. Last, prevent adulterated or misbranded product entering the commerce. Misbranded is easy, you just relabel it. However, it depends on how often that happens. If it really happens, then your labeling plan has to be redocumented. And if all these things happened really often, then reanalyze food safety plan should be done. And this is, we're not going to cover today. This is going to talk about the chapter 13, the verification and validation procedures. Okay, the last thing we want to talk, corrective actions required records. We need to do the actions taken to identify and correct the problem. The actions taken when necessary to reduce the likelihood of the problem will reoccur. We already mentioned that you have to look at the historical corrective actions, reevaluate it if possible. If it's only a minor change, then your food safety plan does not need to be reanalysis. If there is a major change, then a formal reassess is needed. That is even in coding, reassuring forms, retraining employees. There is a change in the phasing of the food processing. You have to remanage the labeling. Even the last one is informing the supplier of the raw material. There's something wrong there. We all maybe have to take a deep look. The last thing, the documentation of the amount of the product is infected and how we deposition them and make sure they are not going to the market. This is a form which is show you the example, which is a corrective action, how they do. So you're encoding the date of record, very important, which day you did that, lot number. This is ask you to do a historical tracing back. Is that a lot number is always there? If it's always there, maybe that storage room has a problem. You need to find it. Date and the time of the problem. You need to see sometimes it's always happened in the afternoon. That may be related to the temperature. Maybe the cooler in that higher temperature, it doesn't control very well. In the morning, maybe it's good. So that the time is important. What is the root cause problem? Actions taken to restore order to the process. Personal taking action, how we did that. Amount of the products involved in problem. Evaluation of product involved in the problem, how we did that. Final this position. Never forget you have a name and a signature and the date. This is important for double check all the third party investigation. We call it a validation, verification. We want to see it. Who did that? Okay, next one. We mentioned earlier about operational limit. So here we want to talk a little bit about that. Operational limit is a value more strict, or we say more conservative compared to the critical limits. This is used by operator to reduce the risk of a deviation. They borrow the definition is actually coming from the FDA, another document in 2011 from the National Seafood HACCP Alliance. Now, why we can do an operational limit? Why they can be established? First of all, is a quality reason. Sometimes we see long time cooking, a little bit conservative value maybe will improve the quality of the products. Second is that we want to avoid the deviation. We have a next slides will explain that. Because the more strict value, especially thermal inactivation, it will control the critical limits, gives you corrections instead of you directly jump into the corrective actions. Last one is account for the process variability. Okay, you will have to see the variability of you, how variation of the product it happens. But here I have to mention that the operational limit, the use is really depends on the situation in the specific plant. So for example, a beef products, FSIFS had a recommended temperature 71.1 degrees Celsius. You said, I want to cook to 74 degrees Celsius. A more conservative value, sometimes it doesn't work. The reason is for the beef products, we are talking about juiciness, flavor, and the tenderness. And the research survey has been showing 80% of the people are willing to pay $5 if your tenderness is increased about 10%. If you really set up a very conservative operational limit, then that tenderness is going to be decreased. So you maybe make sure the safety, but obviously you decrease the quality. So there is a preliminary or the third-party validation study needs to be done to see the operational limit really is improving the quality, is not decrease the quality. So this gives you some of the example. Let's say I set up a cooking temperature, 165 degrees Celsius, 165 degrees Fahrenheit, 74 degrees Celsius. This is a critical limit. I have an operational limit is a little bit higher, 2 degrees Fahrenheit higher than that. During the cooking, if I see that temperature is decreased, however, it is above critical limit, then I only need to do some minor process adjustment. This will prevent a deviation, will prevent a more complicated corrective action. We mentioned the corrective action, the procedure. We don't want to get to that. That's the reason the operational limits have to do. There is an advantage about that. However, if the temperature has been dropped below 165 degrees Fahrenheit, 74 degrees Celsius, that means the corrective actions has to be taken. So that means the corrective action is required. So let's fill the table at the end. The corrective action, hold the product back to the last good check and evaluate. Rework, discard, or release, well documented. Determine root cause, retrain, or correct as appropriate. I would say that here it is a conclusion. I do not think you can just roll these sentences because these sentences are pretty general. It almost fits all the products. Based on your own situation, you have to put more detail. For example, if you are cooked to ready-to-eat meat, then you have to say you're cooked to ready-to-eat meat. In which situation? If you are rework, then how are you going to rework it? Is you discard? how much amount you discard, because economic benefits is always has to be consideration in the company, in the industry, especially the very small entrepreneurs. So this is actually is only a template for you to fill, not is something you can directly borrow from the document. Okay, the summary, process preventive controls summary. Procedures must be documented for the process-related hazards, requiring a preventive control identified through the hazard analysis process. These controls usually we identify as critical control points. In order to establish critical control points, a specific control is determined by the nature of the hazards and the nature of the preventive control. For each process related to preventive control identified, the following must be recorded as appropriate. Parameters, values, that is referred as critical limits, must be met. Monitoring procedures, including what we do, how often we do, and who do that must be documented. Corrective actions must be identified that implicate the product. Determine the deposition, correct the cause, and determine the preventive controls are working again. Verification and the records need to be well documented, and obviously this will be the later section, like I mentioned, is in chapter 12 and 13. So thank you very much for the invitation, and I hope you enjoy the talk. It's a little bit long, but I'm more than happy to take any questions if there are some of the further discussion.
Stephanie, you're on mute.
I'm on mute. Sorry. So anyone